Hello everyone and welcome to this fourth tutorial about Tinkercad. In this tutorial we're gonna see how we can turn on and off a LED according to the state of brightness using something called photoresistor. And that means if it's day, so the brightness will be high and the LED will be turned off. And if it's night, in which the brightness became low, so the LED will be turned on automatically. So let's see how it will work. Okay, so this is our circuit. We have here an Arduino Uno, a breadboard, a LED which has a resistor connected to his negative side, which is connected to the ground as you can see here, and the positive side, which is the anode, is connected to the pin number 13. Okay, and we have also a photoresistor which is called also LDP for light dependent resistor. It is a light sensitive device most often used to indicate the presence or absence of light or to measure the light intensity. In the dark, its resistance is very high, sometimes up to 1 mega ohm, but when it is exposed to light, the resistance drops dramatically, even down to a few ohms, depending on the light intensity. So, when the value returned by the photoresistor is low, and that means its resistance is so high, we're gonna light up the LED. And if the value is high, and that means the resistance is low, we will turn off the LED. Okay, so how we connect this LDP with the Arduino Uno board? So first of all, we connect a resistor with one of the legs of the photoresistor, and doesn't matter which leg. And then we connect the resistor with the GND, which is the ground, as you can see here. And the other side of the resistor, the side connected with the LDP here, must be connected with an analog pin which is A0, for example. And finally, the other leg of the LDP will be connected with the 5-volt pin. Okay, now this is our circuit. So let's go to the Tinkercad website and create it. Okay, so first of all, I'm gonna create a new circuit from here. And here we go. So I'm gonna need, as I've said, an Arduino Uno R3. So I'm gonna take it and put it here. And I'm gonna need also a breadboard. So I will take it and put it here. Otherwise I have a problem with this breadboard. Okay, here we go. I'm gonna need also a LED, so I will take this LED, a resistor, so I'm gonna take down this a little bit, and we're gonna need a photoresistor. Here we go, this is our photoresistor, and I'm gonna put it here. And we're gonna need also a resistor for our photoresistor. I will connect it here and I will turn it using this button, rotate. Okay, here we go. And oops, and we get it and connected to the leg of our photoresistor. Okay, now I will start by connecting this negative side of the breadboard with the GND. So I will take this and go to the GND pin in our Arduino Uno. Sorry, here we go, and I will change the color to black. Always I want to put the negative side with black color to make the things easy. Okay, then I will connect this side of the resistor with the GND, so like this, and this resistor also with the GND like this. Okay, then this side, as we have talked, must be connected with the analog pin, which is A0 for instance. Okay, so we go here. Oops. Okay, here we go. I will change the color, or I will leave it green. Okay, then this side will be connected with the 5-volt pin. Okay, here we go, and I will change the color to red. Okay, then this side, the anode leg of our LED will be connected with the pin number 13, for example. You can link it in another pin as you wish, pin number 12, 11, it really doesn't matter since it is a digital pin. Okay, so this is our circuit. It's ready, I think. So now let's write our code. Okay, so we go here to code and change this to text, continue, and I will start by deleting these instructions as usual. Okay, and I will start by creating two variables before the step functions. So I will write here int ldp value equal to 0. In fact, LDP value is the value returned by our photoresistor. So the value returned by our photoresistor, it will be stored in this variable named LDP value, and I initialize it at the beginning as 0. It doesn't matter really, because it will change it later. Okay, then I will add another variable, which is the threshold variable, which represents the value of when the light will turn off. So I will put it 40, for example. You can change this value as you want, depending to your wishes. Okay, then in the step function, I will specify our pin modes as usual. So I will write pin mode 13, which is our digital pin here connected to our LED. It will be output as we have seen in the previous tutorials. And by the way, you can find the links to our previous tutorials about Tinkercad in the description below. Okay, and I will not specify the pin mode of the analog pins, because they are always input, as you can see here. Okay, then we go to the loop function, and the first thing we need to do is to read the value of the photoresistor. So we write, we said that we're gonna store the value returned by our photoresistor in the LDP value variable. So we write LDP value equal to analog read, because we have used an analog pin, so we write analog read to read the value, and we specify the pin, which is A0. Okay, and then we write delay. Okay, I'm gonna return delay 500, and that means that the value of the ADB will be updated every half second. Okay, and now accordingly to the LDB value, I will turn on or off the LED. And that means, sorry, and that means if the LDB value is low, is low, and that means is less than the threshold here, which is 40 in our case, so I will turn on the LED. Else, if it is greater than the threshold, I will turn off the LED. Just I will correct this, it's threshold. Okay, and we're gonna write so an if block. So if we have said so if LDP value less than threshold, so in this case I will turn on the LED. So we write digital, right? You have seen in previous tutorial how we turn on the LED, so I recommend you guys to see our previous tutorial. So we write 13, which is the pin connected to our LED, and we give it the value high, which is 5 volt. Else, otherwise, and that's mean if the LDB value is greater than the threshold, so we're gonna write digital, right, and 13 and low. So we're gonna turn off our LED. Okay, so first we have read the value returned by our photoresistor using the analog read function. We have put a delay function and give it the value 500 milliseconds, and that's mean we will update the value of the LDB every half second, and then we have tested our LDP value. If it is less than our threshold, which is 40 here, I will turn on the LED, else I will turn off the LED. So this is our program. Let's run the simulation now and see the result. So I'm gonna close the code here and hit the start simulation button. Okay, we have an error here. It seems like a code. We have threshold. Oh, I wrote it wrong. It's threshold and not threshold. Sorry guys for that. So I'm gonna start the simulation again, and here we go. So as you can see now, it is night in our photoresistant, and that's mean the resistance of our photoresistance is very high, and the value returned is low. It is less than 40. So when I move to the light, as you can see here, the LED turns off. Return to night, the LED turns on. Go to the light, the LED turns off. Okay, here we go. So this was how we turn on and off a LED according to the state of brightness using a photoresistor. We will see in next tutorial how we can create more projects using this amazing website. And if you are interested in using real components to create this example and many other things, let us know in the comments of this video to create more tutorials about Arduino. I hope that you have enjoyed this tutorial. If so, don't forget to like this video and subscribe to our YouTube channel to be informed about our next tutorials.